Thank you. Thank you for having us today. I'm Gerald Gaughan, and we're based out of Chicagoland here. We have the local region, Wisconsin, Illinois, Indiana, Iowa, and other regions in the area. But if any of the group is within those areas, we are your contact people. I'm Gerald Gaughan, and
I'm Kyle Rudolph with Carrier Rental Systems as well.
So we're happy you could make it today. And this isn't a long presentation. Carrier Rentals just wants to let you know the things that we can do. There's an awful lot of things we can do. We can solve almost any temperature and humidity control problem that you have, and we can do it really fast if necessary. It's not our method we want to live in all the time. We'd rather have a day or two, but you know, we do make it happen very fast. So thank you for spending some time with us today. So Carrier Rental Systems is a global provider of temporary temperature control equipment. We offer engineered solutions. This is for specialized cooling, heating, dehumidification, and power generation. We focus on providing the best engineered solution to solve the customer's problem. We're allowing building owners and manufacturing facilities to operate under adverse conditions. What we're looking to review today is the benefits of renting, why it's important to choose the right rental company. We'll give you an overview of our equipment, and we'll get into some application case studies. Why does it make sense to rent? The main things are immediate need due to equipment failure, special projects where temperature equipment is required, future need due to potential equipment failure, examples, contingency plans, planned future outages of equipment, lack of capital to purchase equipment. We have over 100 depots and 600 employees worldwide. From this map, you can get a feeling for where our locations are, both Carrier and Spot Coolers. We're all part of the United Technology Corporation group of companies.
Carrier Rental Systems, at Carrier Rental Systems, we provide service and engineering. Some of the reasons people rent, it's cost reduction efforts. People choose to apply their capital to equipment that they need for production. For instance, we work with pharmaceutical companies from time to time, and I've had someone at a pharmaceutical company tell me that they like plowing their capital into the vessels and different equipment for manufacturing the pharmaceuticals. As long as they're making money, our equipment's out on rent. They continue to utilize that for the cooling. If there's, for whatever reason, they're no longer using that drug, or a better drug becomes available and that line's no longer viable, they can send our equipment back, but they put their capital towards the most efficient use where they can make the most money with it. Another reason we do it is turnaround and shutdowns. If that's different types of plants, whether it's a refinery or any other type of plant, they'll have shutdowns and they'll need cooling equipment, or they'll need different equipment for different applications, whether it's a dehumidifier or air handlers. During that process, we're able to provide that for them. Some people prefer to have the equipment, prefer to rent equipment because of, literally the way that they're able to write off the rental for tax purposes. Instead of it being a capital expense, it becomes an operating expense, and there's certain companies that just prefer to do it that way. And then ultimately, we have other companies that they don't want their equipment there all the time. They bring it in, they bring it out, but we have one in particular where they rent the equipment. They have annual inspections from government agencies, and frankly, they just like to have the equipment rented because it's not there at that point in time, and it just, it streamlines the inspection process for them, ultimately. What's in it for you guys? whether it's an engineering firm or a mechanical contractor, it allows you to position yourself as a total service provider for your customer. Ultimately, when a piece of equipment is going to be down, you know it's going to be down, and you have to deliver that bad news. It also allows you to deliver some good news at the same time. Yes, it's not the ideal situation for them, but ultimately there is a solution and a quick solution for their problem. It allows mechanical contractors specifically to utilize their labor force in order to set up and tear down of the temporary equipment. A small job could take a guy, half a day to a day. Larger projects, it could be several days, several guys over several days, or several shifts doing 24-hour installation, depending on the urgency of the project. It allows you guys to install additional installations, capital installations, such as taps for the fluid connections or the electrical connections. Ultimately, a lot of times, if we're doing a contingency plan, the customer will allocate some funds and they'll pull their mechanical taps to their fluid system to the outside and valve it off so that they're able to, God forbid, the day that the event the contingency plan is to prevent takes place, they're able to pull up a truck and connect in a chiller just as quickly as humanly possible. Other times it's you're installing taps at 2 in the morning on a Saturday night on overtime. So an additional positive for mechanical contractors as well is it allows you to we can run rent the equipment directly to you, at which point you're re-renting and invoicing a customer for the mechanical equipment. And when you do that, we typically give a discount to mechanical contractors, so they're able to put a small markup on there, as well as it makes everybody's sales numbers look good. Carrier rental systems, what makes us different than just about everybody, not just about everybody else, but most people in the industry, is equipment testing. Every piece of equipment that we send out to a job site, we have an in-house test stand at which we're testing equipment to capacity prior to it leaving our warehouse to the job site. What this does is it gives us the greatest chance of everything coming in. I like to think of us as the white knight riding in to save the day. And when we do that, it gives us the greatest chance of that equipment operating, as it's intended once it shows up on site. We do have our technicians, our crew. All our technicians except one are 20 to 25 year guys, 20 to 25 year employees. Frankly, I believe that they're the best in the business, and we owe them a debt of gratitude for everything they're able to provide for us, the knowledge and the efforts that they put forth. We can do on-site installations, but typically, overwhelmingly, that falls to the mechanical contractor at the site. Our guys are better suited in our shop working on our equipment. Engineering and technical assistance, again, our engineering team has been here for 20 years plus. Again, I believe they're the best in the business. When we bring them technical problems to solve, when we bring them unique situations, unique applications that we're trying to find a solution to, we find solutions and we know they're going to work when we bring them out there. So, and ultimately, emergency service. We're available 24 hours a day, 365 days a year. All of us sleep with our phones next to our beds. It's can be hard to call somebody at 2 in the morning if they haven't told you to call them at 2 in the morning, but we would be honored to get that call. It's what we do. We enjoy it, and we do it 24 hours a day. Our crew is on call 24 hours a day as well, and there's times where I've had to get a hold of people at night, and on like the first call, 75% of our people answer their phones in the middle of the night, which I don't think you'd find another business in the world that does that. So some of the equipment that we have available, we can do anything from a single ton of air-cooled chillers all the way up to 1,500 tons of centrifugal on a single trailer. We can do packaged air handlers, packaged air conditioning units. We can do hot water and steam boilers, cooling towers up to 1,000 tons on a single trailer, and anything that we have, we can put in parallel in order to achieve the desired capacity. Here's a quick rundown, some pictures, and just a quick rundown of the equipment that we have. For air-cooled chillers, we can do anything from a single ton up to 500 tons on a single trailer of air-cooled chillers. Water-cooled chillers, we can do. These are nominal tonnage units that are shown here, but we can do anything from a single ton of water-cooled all the way up to 1,500 tons centrifugal as well. Air conditioners, these are purpose-built machines that we've built and refined the design over years. They're palletized, they're rugged, they're movable, they're portable for different applications. We have some that have high static that'll be used in high static applications. And again, we can do a single ton spot cooler up to an 80-ton industrial air conditioner. We also offer spot coolers as well. Small units. One unique thing that we do offer in the spot cooler that not a lot of people know about, not everybody offers, is we do have water-cooled units, which seem to be increasing in popularity. They'll, for instance, if we have a 5-ton unit, it'll connect up to essentially a garden hose, a city water tap. It'll use a water red valve to control the water flow. The water will go to waste for the condenser, but ultimately you're able to reject the heat from the space and cool the space without like a duct plenum or getting some form of outside air for the condenser for the unit. And those are great for different applications inside a building where it's hard to reject that heat. And
Just talking. It goes up.
You got to click on it. That took me away. Oh, sorry. Our cooling towers, we have from 100-ton cooling towers, nominal ton, to 1,000-ton on a single trailer. The top picture on the right there, you can see the 1,000-ton cooling tower. It literally takes up a 50-foot trailer. Air handlers, we can do small steam coil air handlers, all the way up to large scale air handlers. We'll cover some of these in the projects that we have a little bit later on here. But basically anything from a few thousand CFM all the way up to 88,000 CFM. One real nice unit that we have that's pretty unique, we can do 50,000 CFM at high static. Use that a lot in hospital applications for air handler replacements. That's been pretty popular for that. And then we can do desiccant dehumidification as well, from small to large, and those can be operated by natural gas or entirely electric. Generators, we offer generators with our equipment to power whatever we have. In order to, if the application calls for it, we can provide a generator to power the cooling equipment as well. Typically, most people end up finding electric once they look at the cost of diesel fuel, though. Boilers, we do hot water, we do steam boilers. We're able to provide those. In the wintertime, it kind of doesn't seem too terribly applicable today, but in the wintertime, those are the emergency item that we're typically dealing with, and we're able to turn those around rather quickly as well. And then we do gas-fired, direct and indirect fired heaters.
We're going to take a minute and just talk about our approach to the heaters. We're on construction sites, so if you're working a construction site, a lot of mechanicals are asked to provide the heat on the site. This slide is showing you the difference between a makeup air heater and a recirculating heater. Makeup air heater brings in fresh air from outside, heats it up, increases its ability to hold moisture where it's pushed through the space, picks up moisture as it moves through the space until it gets to the building wall where the building naturally breathes and carries the moisture outside. Below it, you can see a recirc heater in comparison to a makeup air heater that's pressurized into space. The difference between these two heaters is a makeup air heater has a squirrel cage blower. It's a 10-to-1 air ratio versus a propeller fan on a recirc heater that's a 4-to-1 air ratio. we get a couple hundred feet of push out of our large heaters versus a recirc heater. You're generally only getting about 10 feet of push. A couple other major point differences is the makeup air heater brings heat into the space at about 160 to 170, so it lays in the space longer. A makeup air heater, the heat comes out somewhere between 300 and 350 degrees. That hot air causes a thermal shock in the area. It causes a lot of infiltration too, because that hot air rises. So if you're doing a concrete pour and you need the underdeck heated, the recirc heater is the right heater. That can be used in construction sites, but if you're going to look for moisture control so you don't get discoloration of caulk, discoloration of grout, you don't have mold remediation because you're constantly bringing in fresh air and controlling the moisture level within the space. So a big part of our heaters is the construction market that we work with a lot of mechanicals on. We also have heaters for all different types of other applications, electric heaters, indirect fired, boilers in conjunction with air handlers, things of that nature. What we're typically doing is we're going to come out and visit with you guys when you have an emergency, and we're going to do a job site analysis. So this is an example form where you're looking to collect a lot of data when you're out there. Our years of experience are very helpful at the site to make things progress fast. From that, we're usually putting together some plan, a flow schematic, ideas on what it's going to take. We have many standard drawings that we use that show heat exchangers and bypasses and runaround loops. We're very versed in this. We can help you with it. These are a cooling tunnel application, a warehouse that had $25 million worth of cheese in it that they lost their system, a guy making a chemical process, and he has to cool a batch off once a day, and he has a condenser on it on top of that. From there, we put together the systems that end up coming out to the job site. Here's an example of a 35-ton chiller system. It has a chiller there you see in the foreground, you see a pump, and you have a loop that you're isolating through a heat exchanger. That's the unit off to the right. So the inside building, we have a quench tank that's in there that has some oils in it, so you don't want that to go through the chiller, and it's isolated across a heat exchanger. We'll help you come out, size this equipment, see what's needed. If you're in an emergency situation, we can get order of magnitude going real quick for you guys too, until proper analysis can be done of the job site. Here's an example of a 200-ton air-cooled chiller. Similar situation, you're seeing a chiller to the right. To the left, you're seeing a heat exchanger. It's another plant that had to have the process water isolated from the chilled water loop. Many times, if you're operating a system and they have to have water inside, we're using a similar setup as this, where we have a glycol loop for outside for low winter ambient protection, and then the heat exchangers going inside to cool the process water, because they don't want to circulate glycol throughout their plant for many different reasons that could be.
The next application that we're showing here is a fairly relevant project, because it's the Hines VA Hospital in Hines, Illinois, right here in the western suburbs, just off of 290 on First Avenue. This is a project that we've done in subsequent years over the last 2 years, and it shows it's a pretty good visual representation of what our capabilities are, I think. Ultimately, this is a 19XR 7272 centrifugal water-cooled chiller with a 1,000-ton cooling tower, and then all of the accessories, pumps, etc., that go along with a piece, a project of this size. So you can see the cooling tower sitting in the rear there, the pumps off to the right, and the chiller in the foreground there. This is actually a brand new chiller that we've just brought into the fleet recently. So you can see it's very new, very sleek looking. So here's a quick picture showing the pipe coming off of the cooling tower to the suction of the pump, and then ultimately the hoses are sending the water to the condenser on the water-cooled chiller.
Here's another plant. This plant had an ice building system, and they weren't able to keep up with peak loads. So they brought in a couple 450-ton chillers with heat exchangers to isolate it. So they have 900 tons. As the system was balanced, we were able to achieve running 31-degree water. They're getting 33-degree water out of the unit. So generally with heat exchangers, this isn't always possible. It is. It's something we can analyze for you and see what it is going to be to fit your application. But in this case, we're running a glycol on one side of a heat exchanger, and we're able to get a 33-degree fluid out of the other side of it. Here's a different job showing a courtyard that we turned into a bit of a mechanical room. We have a bunch of air handlers. There was no space within the facility. This is a meat packing plant, and these are air handlers that are controlling the temperature of the space to be 40 degrees. We're doing lots of air exchanges in there because of the nature of the project and the meat packing plant. You can see these are custom-made plenums with our units sitting outside, so we're pulling the air in through it, a 40 degree, and returning it to the space. And as I mentioned, you can see it's for a meat packing plant.
This is a project that we did. It was a plastics manufacturing facility. Ultimately, they were having issues, 3 issues. Their product was having issues with the high humidity and temperature in this facility. Their people were having an issue again with the high humidity and temperatures in the space as well. The space is hot to begin with in the summertime, and then coupled with the furnaces and all the heat that's being generated by their equipment, becoming unbearable for their people. And then additionally, an additional problem that we were able to address for them was they were having issues with pests. So they had so much exhaust running that they were running ultimately the building was running at a negative pressure, and pest infiltration, bugs, was just rampant, and it was food packaging that they were ultimately making, food and medical packaging that they were making. So they had set up these collection systems, filtration systems that just circulated the air, but it sucked in just massive volumes of air in order to collect up any bugs that any insects that had infiltrated the space. So at the beginning of the project, they actually sent off all the filtration with all the pests that they collected, and they were collected and quantified, and the different species of bugs were tallied, and they were averaging somewhere around 27,000 bugs in the filters at the outset of the project. Once we brought our equipment in which we had it online for a full month, they collected all these filtration systems, and because of what we did with the positive pressurization of the building, we were able to turn it around that they only had about 200 insects that they collected in all of their filtration, which is, I think everybody would agree, a pretty significant change from 27,000 individual insects down to about 200. It certainly made a huge difference in their facility and alleviated a huge problem that they were having. In the next slide here, they're a really cool company to work with because they're just so data driven, and they collected everything. And I loved that because it gave us a lot of data on what we're doing. A lot of times we perform projects, and anecdotally we know they work, but to see it laid out, what we were able to accomplish is pretty cool. On the left, you can see the temperature, the dew point, and the relative humidity prior to our equipment taking place or being installed and started. And on the right, you can see what we were able to accomplish as far as the dew point and the relative humidity once we came in, once we had our equipment, once we had our system up and running. They were able to maintain the dew point between 50 and 60 degrees Fahrenheit, and the temperature somewhere around 80 degrees. The target was about 80 degrees. We averaged a little bit less than 80 degrees over the duration of the project. So we were, quantifiably able to achieve their goals, as you can see on this graph here. The next project, we did an office cooling. This was in the city last year, Anybody who's ever worked in the city knows that space can be at a premium. So what we have here is we have a water-cooled chiller, a carrier water-cooled chiller, in a shipping container that we brought out to the job site, and we were actually able to move it into place in a garden-level parking garage on the building, and we were able to connect the electrical and the hose to the machine, and then ultimately the mechanical contractor that we partnered with on the project was able to run PVC piping up the side of the building using Unistrut to support it, and then we transitioned back into hose at the roof for both the condenser and for the evaporator after the chiller on site had failed during the peak summer months. So this was a relatively quick turnaround project. This was all completed within about a week from the first time we were walking the site to delivering the equipment to ultimately installing all the piping and all of the work that it took to get this unit up and running. Another project that we have here, this probably speaks a lot to anybody who's with an engineering firm on the project or on the call. This is a hospital in downtown Chicago, and they were doing an air handler replacement. They were looking for about 50,000 CFM at like 6 inches of external static at 55 degrees saturated. And we had a single air handling unit that's essentially got two large squirrel cage blowers in there with 50 horsepower motors and VFDs, which we were able to utilize in place of the existing air handling unit when it was taken down. This was tied into the space to supply the outside air, to meet the outside air requirements for the hospital while they replaced their air handler over the summer. You can see that they elected to hard pipe everything. A lot of hospital applications, they'll like to hard pipe things, especially if they have some lead time on it. And you can see it's pretty nice looking pictures with the Victolic piping and the duct on the left there. Ultimately, the equipment was out there for about 3 months and stood in for the existing air handler while they built a new air handler. It was a fan wall application in the basement, so it allowed the continued operation of the building of the facility while they built the new air handler. Ultimately, with this project, we started out working on this probably more than a year in advance before the project actually took place. Most people think of rental air conditioning or rental HVAC equipment as an emergency need piece of equipment. But I think this shows it's a good representation of the other types of projects, the planned projects that we're able to do, especially working with engineering firms. With these projects, whether it's just simply a quick budgetary number for the owner to say, hey, you can do this project if you do it in the summertime. It's going to cost you X number of dollars for cooling, or in the wintertime, it's going to cost you X number of dollars for temporary cooling equipment, all the way up to, assisting in finding a solution for the project, such as this, where we're able to find a unique piece of equipment that's able to stand in and allow the project schedule to continue as planned. We understand that there's a long-term view in dealing with different engineering firms and these types of projects, that it's not the kind of thing that we're going to turn around tomorrow, but it's the kind of thing that we're in it for the long haul, and we really do appreciate having those conversations and appreciate the opportunity to work with you on those kinds of projects. So if that's something that makes sense for anyone, we would certainly welcome the opportunity to have the conversation with you.
This is just another example of being able to set up a remote mechanical room. This was a job where the wind turbine blades at the tip of them had some cracking, and a specialty company came in from Italy that had the knowledge of fixing it, and they had to have a temperature and humidity controlled room. What you're seeing there is 200 tons of air conditioning. So a 50-ton air conditioner has 4 20-inch rounds in and 4 20-inch rounds out. You're seeing a couple generators that are supporting that and running that equipment. Another application was at a food plant, actually a candy manufacturer. They had 3 systems. They had redundancy, and they still had a massive failure that brought the whole plant to a screeching halt. They were making a negative 8-degree fluid, I'm sorry, negative 10, coming back at negative 8, and this went to many different parts of their process, cooling tunnels, that they had the candy going down to a drum that was turning, and the gooey center of the candy would pass over about a quarter of the drum and then be scraped off and go into the tunnel. Just the diverse applications we can get involved with. This was calcium chloride. There's a couple more after this one. So, as we said, we are Carrier Rental Systems. There's Kyle's contact information as a technical sales rep. Myself, Gerald Gone, I pronounce like Gone with the Wind, as a technical sales rep. This really concludes our presentation. If you guys have any questions, feel free to call us. What we do ask, as we mentioned earlier, take a minute, put our number in your phone, call us in the middle of the night if you need us. We really like to come out and meet you so you can see the face that you're calling in the middle of the night, get you order of magnitude. If you have critical downtime with the customer and you're going to tell them, hey guys, your unit's down, it's going to be 2 weeks before we can get you back up and running, but there's an alternative. Take that minute, call Kyle, call myself. We'll get you some order of magnitude, and you can share with the customer, hey, you could do this. That's the best time for a mechanical contractor to work with his customer. He keeps him satisfied, and he's able to solve his problems. Kyle, anything with you?
Just to reiterate what Gerald said, whether it's a long-term project that we're planning out for a year or 2 from now, whether it's budgetary numbers or if it's an emergency situation in the middle of the night, we're here. This is what we do. We love doing it, and we would certainly appreciate the opportunity to help anybody out.
Thank you for your time.
Gerald, Kyle, thank you very much for joining us today. Everyone on the webinar, this was recorded, so if you want to share it with other people in your office or whatnot, once Ryan gets that uploaded later today, we can always send out the thing. If questions come up, you got Kyle and Gerald's numbers right there, but you can always ask your territory managers or inside engineers if you misplaced that or need some additional support for them. Otherwise, again, thank you, Gerald and Kyle, and thank you all for joining us for our Monday webinar.